Welcome back to Let Us Learn to Lead video series on free open source software designed by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra, a dynamic mathematics software, is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing a worksheet to visualize a cylinder. For preparing this video lecture, I used Windows 10 operating system, licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we are going to design. We are going to tell the children that what is a cylinder that contains two parallel circular bases and connected by curved surface. We will try to control the radius of it. Then from that we will try to get the height, and then we will get the cylinder, and we will tell them they can rotate, and they can rotate it, and they can find out what is its radius and how it looks like. And we can explain them what is the formula for lateral surface area. A separate color is there for lateral surface area, then total surface area, then the volume. And one more advantage you are seeing over here, that the lateral surface area is given in the form of corrected to one decimal place, and not only that, it is given in the form of a fraction also, so that the child can understand both of them. There is a way to express it in the form of a fraction also. Let us try to design this dynamic worksheet from scratch. For that I have taken GeoGebra Classic 5 worksheet, and I have taken geometry view. In the geometry view, first I will start with a text. I will just type cylinder. Okay, we are going to explore cylinder. You can tell the explanation for the cylinder. It is a three-dimensional solid it is having some curved surface. Okay, now we have to start with a slider for radius. You can call it as R, or you can call it as radius. It cannot be negative, therefore it starts with 1. I will go up to 10, and with increment it is left to you. You can have 0.5 or 1, whatever your convenience. If you leave the increment as it is, GeoGebra will automatically take it as 0.1 by default. Okay, the radius I got. Now I want to draw one base, which is the circle. Therefore the circle with center and radius, the circle I have drawn, the radius I will keep it as RADUAUS, radius, which I have made it as the slider. Therefore the slider, when I move it, it will also move. Normally we will try to have it as capital O. You can have it as capital A also, there is no harm, for it is moving. Okay, now we want to have the object property, because it will be the base, where we can give a color to it, and we can have okay, we can give a color to it. Okay, now this circle, you can have the circle, and in the circle is going to be the base. Okay, no problem. Okay, now what we will do is we will go for view the 3D graphics. Okay, we will view the 3D graphics. The circle I have taken, in the object property you can go, and in the color you can have a opacity and with a blue color also, so that you are going to tell that is going to be the base in the 3D graphics. Okay, well, now I got it. Okay, now you can go for the cylinder. Now for that cylinder we need a height, for I want to control the height also. Therefore in the slider I will have one more called height. Height cannot be negative, starts from 1, goes to 10 with increment 1. It is left to you. You can have the increment as per your convenience. Okay, now again click this 3D graphics will open. 3D graphics, the toolbox has opened. Go to this pyramid, go to this extrude to prism, click it, then touch it, color will change. There it will ask the altitude. You type HEIGHT, because that is the slider I have taken for the height. But when I move it, and you are seeing that it moves. Okay, fantastic. Okay, good. Okay, now what we can do is, if you want to show the height, or you can take the midpoint of the top, Okay, now the top one midpoint I have taken, it is a capital A now. Then if you want to show the base, suppose if you want to show the object properties, and you can have it as a blue color, and then you can have its opacity like this. Then similarly on the top also you can select, and you can go to its object property, and you can have the same opacity of 75, and then same color you can take. Therefore a child can understand that these are all the two or base and the top, and the remaining is the curved surface area. Therefore just to have a clear idea about it. Suppose if you want to show the dimensions, radius is equal to, from the object you just to put the radius will be displayed over here. Now if you want to display the height also you can display it over here. Sorry, I think go to the object properties. Okay, in the basic text, height is equal to, from the objects you have to select, you would have selected the height object, or it is height. Okay, therefore now height and this one is visible to the children now. If you want to show it to the children, suppose if you want to show it, I think what you can do is you can take a point on the object, then you can take this segment, the segment you can join it to show the height, these two you can join to show the radius. So the child will come and rotate it and then check out what is the meaning of the height, what is the meaning of the radius. Okay, now everything they have got it very easily now. Okay, now let us try to explain to them what is the lateral surface area. Okay, lateral surface area formula is 2 pi RH 2 multiplied by basic symbol pi will be available there. Okay, then again multiplied by 2 pi radius RADUS radius multiplied by HEGHT height. Okay, now you can calculate that LSA also. Okay, the formula is over here. Now go to this view, input bar you take. In the input bar you type LSA is equal to 2 times, therefore 2 multiplied by 22 by 7. I am not taking pi, I am taking it as 22 by 7 multiplied by the radius 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 multiplied by HEGHT. Now I think already we have discussed it. Whenever you are typing any number, except this number, whenever you are typing any variable, suppose if its color is not changed into blue color, the meaning is it is not available with GeoGebra. You should be a bit careful with that. Okay, is it okay? Now okay, now I am entering it. Let me put it somewhere here so that I will get a space for typing. Lateral surface area is equal to, from the object, let me take LSA. Okay, now you got the LSA over here. Okay, suppose if I change it, I think it will be converted now. It will be very simple. When I do it, then it is corrected to 1 decimal place it is showing. If I make it as 7, 27 and 7 get cancelled, therefore you are getting a good number. Okay, now we will go for expressing what is total surface area is equal to, now pi r square, therefore pi 2 pi r square, therefore 2 into pi. You can explain to the children that why we are doing it. You can explain to the children. Radius the whole square, from the symbol the whole square over here, and plus you can directly write lateral surface area. Okay, plus lateral surface area. I think the child can understand that what is the meaning of this. Okay, okay, plus lateral surface. Okay, now in that formula bar, once again you can type TSA is equal to 2 times pi r square, 1 pi r square on the top, 1 pi r square at the bottom, for 2 multiplied by 22 by 7 okay, into radius square, again radius, then the square will come from this alpha, then that square plus LSA. Okay, it's very simple. I think otherwise you can once again calculate it, and then you can put the formula for it. Therefore LSA 2 pi r square plus LSA. Now come back to this, and then in that ABC go, and here you can type it, total surface area is equal to, now just now I have made it as a TSA, the TSA has come. Okay, now it has come over here. If you make the radius also as 7, and both the numbers are perfect numbers. Is it okay? Okay, now what we can do in the next one is we can explain to the children that what is the formula for volume. Okay, therefore you can express the volume also. Volume is equal to pi r square h, for pi multiplied by radius square radius. I think we can type like this also. Radius, the square is there, number is here. Okay, multiplied by height. Okay, therefore pi r square h. Okay, therefore volume formula also we have got. Is it okay now? Okay, now remember, I think in the visualizing the cylinder already told that here I have written here total surface area is equal to, once again I have used the formula 2 pi into radius into height. There is no need for it, you can show them directly LSA also to the children. It is left to you. Okay, now we can calculate the formula for volume now. Volume is equal to pi r square h, therefore 22 by 7. You can directly, if you put pi, it will take the pi value directly, multiplied by radius square, or okay, sorry, capital V is equal to 22 by 7 multiplied by radius. Radius, you see it is getting colorly changed into blue, that is very important, into square, then again star, again multiplied by height, HEAGHT. I think no need for that also. Okay, pi r square h, therefore it is getting, I am entering it. Okay, now come back to this 2D view. In that 2D view, go to this ABC. Now you can type volume, VOLUME, volume is equal to, now from the object I can take capital V. Where is it? Okay, here it is. Okay, I have this capital. Okay, now suppose if I have it, then now it is converted into 1 decimal place. Now a child can come and change the radius, they can change the height, and they can check out also. Okay, they can see it. Now the another interesting thing about this GeoGebra is, suppose if you are having it as 150.9, 251.4 and 301.7, you want to express it in the form of a fraction. GeoGebra is giving you an option. I will just do it only for volume. Now the same thing is for TSA, the same thing is for LSA also. Suppose I am typing here fraction text, FRA, okay, FRACTAON, fraction. The fraction text, you just take the number, which number you want to convert it into a fraction. Now I want to convert capital V into fraction, therefore I am putting capital V, I am just putting the enter. Okay, I see. Okay, sorry, I think it has gone. Okay, now once again I will do FRACTAON, fraction text of capital V. Okay, it is changing now. It has come now, this number has come now. This number you can put it over here. Okay, now therefore 301.7 is 212.7. Suppose if you convert it into 7, you see 352 is equal to 352. Suppose if it is divided by some 7, you see automatically it changes. Similarly, you can show it for lateral surface area also. Once again I will do it. FRACTAON, FRACTAON. You remember this spelling, fraction text. Automatically it comes. Now I want it for LSA. Okay, you see, you got it directly. You got it over here. Okay, you can put it in value here. Now in this lateral surface area, what you can do is, in the object property you can go, in the text icon I can put one more is equal to sign, and I can press OK. Okay, automatically it comes over here. Now I can adjust now. Therefore this 1408 by 7 is nothing but 201.1. Therefore now you can just express to the children that 7, suppose if you are not dividing also, then they can get the answer. Really interesting idea over here. Therefore if you are having any fraction. But remember, this can be done only when it is 22 by 7 and other values are perfect numbers. For example, radius is an integer, height is an integer. Suppose if even this radius and height are once again corrected to one decimal place or two decimal place. For example, when you go to the cone, that L will be pi or L, for example, that L will be corrected to one decimal place or two decimal place, where this fraction text will give you something other than this something by 7. As I used pi is equal to 22 by 7, I am getting it. Suppose in the formula, if you have directly typed pi, then this 201.1 you will get, but that fractional text will not contain that divided by 7. For highly interesting, a child can come and he can visualize what is the cylinder, and he can visualize it. You see, already you see it has changed. Okay, now he can visualize what is the meaning of the radius, what is the meaning of the height, and what is the meaning of lateral surface area. You can come and rotate it and then check out what is the meaning of curved surface area, what is the meaning of lateral surface area, and by fixing the number at a particular spot, you can do the calculation also. But highly interesting animated a dynamic worksheet to express the lateral surface area, total surface area, and volume of a cylinder. Thank you. Let us learn to lead.